Energy storage is a technique of storing energy when it's available and using it when it is needed. For example, in terms of solar energy, it is available during the day and not at night, and then there is wind. Using that energy while it is there, then storing it for when that energy is not there. There are many ways of storing energy. Pumped hydro, for example, where you pump water up a hill and then use that potential energy to create energy, electrical energy when it's needed. There is the compressed air. The energy is used to compress air, and then that compressed air is used to turn a turbine and turn it back into electricity. There is also capacitive energy storage, where capacitors and super capacitors are used, again, in exactly the same way. You charge a capacitor and then discharge it. You can use electromagnetic energy, and as the current flows in an inductor, that energy is stored in the field of that inductor, and then it can be retrieved later on as the field discharges and creates electricity. Energy can be stored in terms of temperature, so you can heat compound or a solid object and then use that heat later on for a generation of electricity. And then there is also batteries. There's all types of batteries. There is lead-acid batteries, there is lithium batteries, flow batteries, and many new batteries that are being created now. There are many applications for energy storage. Obvious one is uninterruptible power supply. And then there is standalone power system. There is in remote area, you use electricity, solar and wind, and store it and then use it when we're not available. Then there is grid stability, where there is a lot of solar, and that solar power is fed into the grid, causing problem, and that causes instability for the grid. That energy can be taken away from the grid and stored and used in another time to feed the load. In the case of standalone power systems, you are not dependent on grid. The poles and wires don't need to be there, and all that you need is solar during the day and battery at night. That battery stores the excess electricity that is available during the day and used at night. So you're basically running an independent of the grid. Transition to renewable energy is really not possible without energy storage. You have solar during the day and maybe wind, and maybe you have wind at night, and it's not predictable, it's not constant, and so the loads that we use are constant loads. Battery storage is available from few kilowatt in the form of home energy storage all the way to gigawatts of power. So it can be used for home energy storage, commercial industrial scale energy storage, all the way to utility energy storage with gigawatt hours of energy available. Lead-acid batteries can be used, but lead-acid cannot have many cycles. They run into hundreds of cycles, but the most popular batteries are lithium batteries, but also flow batteries are another good contender that once are developed fully, they will be very good for many applications of energy storage. And energy storage typically consists of a electronic converter, power electronic converter, and a battery. So in terms of standalone power system, then there is a converter that converts solar power into battery energy, and then that battery energy is converted to AC power, which is the normal power using an inverter. Some other energy storage use bidirectional inverters where the grid is available, and then they take the power and convert it. The same converter converts it to battery energy, and then it is also available to convert that energy back into AC and feed the load. Both of them store energy and give energy when it is needed. However, the main difference between them is that a UPS is simpler and it uses lower cost components. They use, in particular, lower cost batteries because they're used for standby application. So they are there just in case the power goes, whereas the energy storage is there constantly and it has to work day in, day out.